Once again, I want to welcome you to this class, Slm303, as introduction to soil survey and classification. So last week we looked at soil formation, how soil forms, and what soil is all about, all of that. Today we'll be looking at another very interesting topic. The topic we'll be looking at today is soil components. Soil components. And as you can see in the diagram on this page, you see this more like pie charts. On it, you could see what actually constitutes soil. You see that soil is made up of 4 major components, which include minerals, organic matter, air, and water. You can see that minerals and organic matter constitute 50%, 2 of them added together, whereas air and water constitute the remaining 50% in the soil. Then the one of water and air could vary depending on the situation, depending on the season of the year. In the rainy season, most of the air spaces would have been filled up with moisture, thereby causing the air then to evaporate. The air evaporates. So then as the soil starts drying, you realize that the water will start going down and the air will start filling up the spaces that is giving way to those air. So principally, we have 4 basic components of soil, and they are minerals, organic matter, water, and air. Of course, mineral constitute about 45%. So whereas organic matter is just about 5%. We talk about minerals. Minerals actually constitute what exactly is soil. We're talking about those components that were formed from weathering processes in which parent materials were broken down, or parent rocks were broken down into fine particles, thereby constituting soil. They include things like sand, silt, and clay. And we say that when when it passes through 2-millimeter sieve, it becomes soil. Then there are different ranges to show whether it is soil, or it is silt, or it is clay. So once again, I welcome you to this very course. I remain Dr. Nathaniel Obasi. By introduction today, we are saying that soil they are a mixture of different things. We say that soil includes things like rock, minerals, dead decaying plants, as well as animals. So soils can be very different from one location to another, but generally they consist of organic and inorganic materials, as well as water and air. So the inorganic materials are the rocks that have been broken down into smaller pieces. So the size of the pieces may also vary. It may appear as pebbles, it may be gravel, or as small as particles of sand or clay. So the organic material is decaying living matter. So this could be plants or animals that have died and decayed until they become part of the soil. Now, the amount of water in the soil is closely of the region, and the amount of water in the soil is one thing that can affect the amount of air in that soil. So very wet soils, like you would find in a wetland, probably has very little air, and the composition of soil affects the plants and therefore the animals that will be able to survive in it. So when we talk about soil components, we say that soil component consists of that soil consists of four major components. As I stated earlier, and they include minerals. We say that minerals can also be an inorganic. They didn't come from a living material. If it's organic, it means they were product of dead and decayed materials. They could be dead plant, they could be dead animals. So those are the ones we call organic particles, organic material. When they are inorganic, it means they are product of non-living things that were in the soil, such as parent materials, such as the rock particles, and several other mineral materials in the soil. Now, we also have water. Water, as I stated earlier, too, and air, they are in dynamic equilibrium, in which when one reduces, it rather increases, vice versa. So the relative proportion of these four soil components vary with soil types as well as climatic conditions. So review the approximate proportions by volume of the four soil components in a mineral soil under optimum conditions for plant growth. Now, mineral components can also be particles, or we say that mineral particles are inorganic materials derived from rocks and minerals. So they are extremely variable in size as well as in components. So now we talk about types of minerals. Types of minerals, and we have both primary and secondary minerals. We'll also be talking about types of primary minerals and types of secondary minerals. Minerals are formed at high temperature as well as high pressure under reducing condition without free oxygen. So these minerals are mainly present in soils as sand and silt particles. They are not crystallized, and they are not deposed from molten magma or lava. So, but then secondary minerals are formed at a very low temperature as well as pressure through oxidation. So they are the weathering product of primary minerals, and they are also either through alterations of their structure or through precipitation. So secondary minerals are usually present in soils, and they exist as clay particles. Now, sizes of soil particles, we have different sizes of soil particles. The mineral particles present in soil vary enormously in size, and they may vary from boulders and stones down to sand grain and minute clay particles that cannot be seen by an optic microscope. So we also have an arbitrary division, which is made by size grading soil into materials that pass through a sieve with 2 mm diameter hole. and the fine earth, which consists of sand, silt, and clay particles. So by this, you should know that when we talk about sand or silt and clay, which are particularly what we know as soil, when you pick some volume or quantity of sand in your hand, you may see some particles that are relatively bigger than what you may consider as soil. Yes, those are not soil because they cannot pass through 2 millimeter sieve or hole in a sieve. So then if it passes through 2 millimeter sieve, then it becomes soil. And they also vary from what we can also call sand, silt, and clay. So they all have different varying sizes that constitute this. Now, when you now pass through some particles through that 2 millimeter sieve, you now realize that some particles may actually be higher than 2 millimeters, and we call those ones coarse fragments. They are coarse fragments. They can also be called gravels or cobbles or even stones. So those are not soils because they are higher than 2 millimeters in size. So when we talk about coarse gravels or coarse fragments, they are with the diameter that is higher than or larger than 2 millimeters and are defined as rock fragments, and they do not include fragments of pulp or concretion. Now, soil texture was referring to the relative proportion of sand, silt, and clay in a soil. The relative proportion of sand, silt, and clay in the soil is what is known as the texture or the textural composition of a particular soil. The method that we use to test for texture may include mechanical analysis or the pipette method. We call those 2 methods could be mechanical analysis or pipette method. It is mechanical analysis when you are using a glass jar to test for it. However, you can as well use a pipette to suck out a particular mixture of sand and all of that, and put it in a small can and all of that, and heat it to try its level. And after you must have heated, you can now test for the percentage sand, silt, clay. And after testing that, the percentage, you test for sand, silt, and clay, but the percentage may as well be derived later by calculation. So it is often the first and most important property to be determined in the soil. It's very, very important we talk about the soil, the soil texture. That is what gives the soil the feel you notice on the soil. When you pick a particular soil component and you try to feel it in between your finger, it is the textural characteristics of that soil. I mean, with that soil is going to be plastic in your hand, it's going to be elastic in your hand, whether the soil is going to be to just be like sandy and all of that. So you now realize that the feel you have in your hand with this soil is what we determine the kind of texture it has. So the textural composition of soils, the different soils, they vary. Then another thing you have to know about soil texture is that it does not vary so easily. It is one of the characteristics of soil that if it has it, in the next 5-10 years, if you check the texture of that soil, it is still likely going to be very close to what you got in the past. So it's one of the characteristics of soil that does not easily change. It does not easily vary. So when you now see a particular sand, that is why this texture is usually a product of the parent materials that a particular soil is made up of. So some soil materials are made up of what we call coastal plain sand. Coastal plain sand, those soils that we see mostly around the seashores. That is what we call sharp sand. For those who are conversant with the soil we used to mold blocks, or the sand we used to mold blocks, or the sand we used to do building or plastering, those are sharp sand. And they are derived from what we call coastal plain sand. Coastal plain sand. Now, we now say that if you have a particular soil that has those coastal plain sand and all of that, when you go to that location, next 20 years, you still realize that you still see soils that are dominated with those coastal plain sand because they are, the textural composition, they are what constitute the texture and all of that of these soils. And you now notice that such soils that are too sandy, they are quite high in sand. When it rains on them, when there is rainfall on these soils, the soils, they quickly drain because they are having very low pore spaces in them. So the pore spaces will just quickly absorb the water down and all of that. And before you know it, all the source of the water would have been absorbed. However, when you meet a soil that has so much clay content in it, you now realize that after that it must have rained, those soils will now absorb moisture, they will now absorb the water, and they begin to swell. And when they swell, they are even begin to exhibit some characteristics of, they draw or they are slippery. So if you move around in such soils, you now realize that you need to be very, very careful. Otherwise, you may have the soil may even pull you down because of the slippery nature of those soils. So these are what we call textures. So texture has so much to do with the way a soil feels. You can test for texture in the field just by mere feeling it. You just test the soil. You say, this soil is sandy because there is no much thickness between your forefinger and your thumb. When you try to feel it, there is no thickness. You see them cracking with each other. That is a soil that is high in sand and all of that. There are tests and there are some calculations you may need to do before you know the percentage sand, the percentage seed, and the percentage clay. So it is said that when describing a soil, since many conclusions can be drawn from this information, water intake or infiltration or water storage in the soil aeration, soil fertility, trafficability, all of these characteristics are directly linked to soil texture. We'll talk about the rate at which soil can quickly absorb moisture and the rate at which water can, even the fertility of soils, all of them have. A soil that is very high in sand does not have much organic matter in it because organic matter is one of those things that has also absorbed water and they retain water. So when a soil is too high in sand, you now realize that it does not really so much do well and all of that when you plant crops. So it also texture also has a lot to do with the fertility of the soil. When we talk about soil aeration, we talk about the movement of air in the soil and all of that. So yes, a sandy soil, air can easily move around it and all of that. Then it also has its own advantages and disadvantages and all of it. So all of these characteristics are, they are determined by texture, all of that. So we now go to weathering. We need to briefly talk about weathering. Weathering refers to the breakdown and changes in rocks. Weathering refers to the breakdown and changes in rocks as well as sediments at or near the Earth's surface. And it is brought about by the biological, chemical, as well as physical agents of or combinations of these factors we have mentioned. So weathering has to be breakdown. We talk about weathering, we are simply talking about breaking down. And what are those things that are broken down? Most of them are those inorganic substances. They are parent materials, they are materials from which soils are formed from. Some of them are rock particles and all of that. So when they are broken down, they now translate, they keep being broken down and all of that into smaller and finer particles until it gets to a point where those particles that have been formed can mix up with soil and all of that. That's the word we call, that's what we refer to weathering. We talk about biological weathering. If what is responsible for that weathering are living things, either rocks roots of rocks when it enters into the cracks of roots of plant, when it enters into the cracks of rocks and all of that, and leads to the breaking down of that rock. Those are biological, or maybe animals and all of that pushing down rocks and they are hitting each other and they are cracking. Those are biological and all of that. Chemical has to do much with when there are some chemical components that are touching or that are affecting those breaking down, all of that. Then we can also talk about physical agents. Physical agent can result as a result of maybe wind blowing down, rocks, and they are cracking with each other and all of that, and a lot of other things, or a combination of some of these factors that have been mentioned. So weathering involves the synthesis of new. Those new can also be referred to as secondary minerals that are of great importance in soil, and they may include clay or they may include clay minerals. Now, physical weathering. Example of physical weathering include processes such as crystal growth, thermal expansion. Crystal growth has to do with when, ice, when water is trapped in maybe in the cracks of rocks and all of that, and it gets to a point where it begins to freezes. Because when water it begins to freeze, it swells, and all of that activity, that process may lead to cracking of these rocks. Thermal expansion, when there is so much hot weather, intense sun beating some rock fragment, it may lead to a kind of swelling and all of that, or expansion, and that may lead to cracks in this body of rocks. We also have moisture swelling and all of that. Abrasion, those are, maybe as a result of wind, abrasion, winds, whereby we may have to begin to move particles together, hitting each other and leading to formation of soil. Now, when we'll talk about chemical weathering in this class, chemical weathering. Weathering consists of the following processes. They include hydration. And when we talk about hydration, it has to do with impact water molecules bind to a mineral or transforming hematite into ferrihydrate. Of course, you can see the chemical formula here. But one thing you should know here is that there is an iron oxide mixing up with water. So when iron oxide mixes up with water, it becomes a process of hydration. Hydration simply has to do with adding water to something. So when this ferrous oxide is mixed up with water, it comes up with a new product, which will definitely lead to a breakdown of a component of rocks or any material that is coming in contact with, leading to the formation of soil. Now, chemical weathering continues. We have hydrolysis. Hydrolysis has to do, when we talk about hydro also talk about water. And this is a procedure in which water molecules split into their hydrogen and hydroxy components. Hydrogen replaces a cation from the mineral structure. Example is transformation of feldspar to kaolinite, and we can see the formula here. We also have another procedure that we call dissolution. The solution. The solution has to do with a kind of water being capable of dissolving many minerals by hydrating the cations and anions until they become dissociated from each other and be surrounded by water molecules. And example is when we dissolution of gypsum. Of course, we can see the chemical formula here. The gypsum here is just a combination of calcium sulfate here with some molecules of water already in it. It mixes up with water again. It will now break up this calcium sulfate into calcium ion and sulfate ion. So you now see this, all of these particles, all of these processes have the capacity of leading to formation of some materials, new materials, so to say. So now, We also have carbonation. We have carbon. Now, this is also a withering that is accelerated by the presence of acid that increase the activities of hydrogen ion in water. So now, example is when carbon dioxide dissolves in water. And this is a process that is enhanced by microbial as well as root respiration. So the carbonic acid is just acid dihydrogen carbonate. That is carbonic acid. It's a very weak acid. Now, hastening the chemical dissolution of calcite into limestone or marble. Of course, we can also see the formula here. Now, we have another one, very common, that is oxidation reduction. Oxidation reduction. Now, all of these are big names, but I'm going to make you understand what oxidation reduction means in a very simple terms. And I know if you learn it now, you will know it. It's, in fact, you will never forget it again. Anytime you see oxidation means addition of oxygen. Oxidation. But anytime you see reduction means removal of oxygen. Now, oxygen simply means the air we breathe. For instance, inside the soil now, when water enters the soil particles, from what we saw in the soil component there at the beginning, when water enters into the soil, inside the soil volume, you now realize that the air inside them will give way to water. It gives way. And when it enters it, so no more air again, it means that there is a reduction taking place. But if oxygen, if that air, that water dries up now, the air will come back again. So this oxidation reduction, their effect in the soil have some very vital, reactions, some very vital process that happens in the soil. For instance, now, if you are used to some of the lowland soils. When I talk about lowland soils, I'm talking about swampy soils. I'm talking about most of the soils that we use even in some places to grow rice, lowland rice, not upland rice this time around. So when you go to such soils, if you open it up, you now realize that you will see some changes in color. You may even see some color that is looking like reddish color inside that very soil and all of that. That is a kind of reduction taking place because there is presence of water, and that water made it such that there is no oxygen in that soil. So there is a reduction taking place. So that situation, ion 3, that is, there is ion that has 3 ion in it. When there is no oxygen, it will now be reduced to ion 2. So that reduction to ion 2 is now a reduction reaction. And that is what leads to those we call it mottles. That patches of reddish particles you begin to see when you open up a soil that is usually used for lowland soils or swampy soils. So that interaction is what we call oxidation reaction. So alternatively, you can also see some soils, especially soils that look like laterite. Laterite is an example. Those soils, you see them very reddish, and all of that. That reddish color is simply oxidation. It's more like, water removing because of the presence of air that has come. We know we have a lot of reddish soils, especially in the tropics, especially in most of our soils within the tropical region. When we talk about tropical region, we are talking about regions that are, experience extreme weather conditions. Extreme weather conditions may include excessive rainfall, excessive sunshine, everything that happens in the tropical regions, they are in essence. So that excessive rainfall now, you now see that it leads to a situation whereby when the rain must have finished and it goes and air comes, that is oxygen now, oxidation taking place. You now see that those soils now begin to turn to reddish, a reddish color and all of that. So that is just a simple explanation to oxidation reduction reaction. And I say that minerals that contain iron, manganese, or even sulfur are especially susceptible to oxidation reduction reactions. So when, for example, iron is oxidized from divalent to trivalent, that is to say that when you write iron Fe now, you now put +2, that is divalent. Then if that is on top, then if it's trivalent now, it is iron Fe, then +3, that is trivalent. So the change in valence and ionic radius causes destabilizing adjustment in the crystal structure of the mineral, and it has a whole lot of effects in this soil. So most common elements in soils, the elements that are found in soils in the highest quantities are as listed here. We have oxygen, we have silicon, we have aluminum, we have iron, we have carbon, and we also have, calcium, potassium, sodium, and magnesium. So these are also major elements found in the earth crust and in sediment. So we now have that oxygen is, of course, the most prevalent element in the earth crust and in soil. And we say that oxygen comprises about 47% of earth's crust by weight and more than 90% by volume. So, of course, we can see here most of the most common elements in the soil, as well as their mean in soil, mean quantity in soil. For instance, here we can see oxygen having like 490,000, in terms of milligram per kg, in particular soil. And this is their mean. And in that order for almost all the soils. And of course, we can see their ranges too. We can see the ranges in which they are in the soil. So generally also in the earth's crust, we have the mean to represent what we are seeing here. We also have the sediment mean as well. All of these are some of the elements in the soil that are most prevalent, and their amount, such as median and range and all of that. So that is that. Now, we also briefly talk about particle density as well as bulk density. Particle density as well as bulk density. What are particle density? What is a particle density? Of course, particle density, we can see it is represented with the symbol we are seeing here. And it talks about the mass of solid per volume of solid. Mass of solid per volume of solid. All of that. So in most mineral soils, the mean density of the particle is about 2.6 to 2.7 gram per cm3 or gram per cm3. Alternatively, if we are measuring it in kg per meters cubed, it becomes 2,600 to 2,700 kilogram per meters cubed. So soils with high content of iron oxide and various heavy minerals have a particle density of about 5.2 to 5.3 gram per cm3, while soils with high organic matter content have a particle density of as low as 1.3 gram per cm3. That is what we refer to as bulk density of soil. And of course, bulk density is just the mass per volume of soil. And we always determine it in the soil because it gives us a lot of insight in knowing how that soil, when we talk about bulk density, it helps us to know whether the soil have enough organic matter. The higher the organic, the higher the bulk density of soil. It means that the lower the organic matter content, because it's talking about mass per volume. So if there are so much organic matter in the soil, it's going to occupy volume, but the weight will be reduced. So when you now divide the mass per volume, you now realize that you have a very lower number compared to a soil that has very low organic matter and probably very high sand content. And when you now, divide, you now realize that you are having a very high figure. For instance, if you divide the mass, you use a cup now to collect a particular soil. And after drying it, to remove the water in that soil. You now measure the volume of that cup and now weigh that soil. And you now divide the mass. The mass has to do with the weight. And you now divide the weight of that soil with that very cup, the volume of that cup that you use to collect it. Then what you are getting is the bulk density. And if it is ranging from 1.6, 1.7, 1.8, it means that that soil is very high in bulk density. There is no organic matter in it. If there are organic matter, high organic matter content in that soil, of course, you will be recording some things like 1.2, 1.3, 1.4, and those are also part of the know whether the soil is good, because if the bulk density is very high, it means that that soil is very compact, number one, and two, the rate at which the roots will even be able to penetrate, the rate at which root penetrates such soils may even be very difficult. May penetrate those soils and all of that. Will be up of an extensive variety of substances, which include minerals and rocks, right? Groups are organic material, inorganic material, air, and water. Thank you for listening to this very class. Thank you very much. And now I am going to stop sharing and now discuss with some of you. I can see that a number of you are here. Sorry, I should have sent you a reminder. This meeting is yesterday, but of course, some of you who are conversant with me will do an open message so that this week is a week of convocation week. So I have to find myself in Abuja for us to be involved in some of the activities that precedes the convocation. So welcome all of you. I can see Adigon Oluwatosin Oluwatoyin. I see Ajayero Raphael. I can see Janet. You are all welcome. I'm very happy to see you all. I'm just very happy to see you. Even despite trying to remind you, still try to be here. I'm very happy. So I don't know if any of you have any question related to what we have learned this afternoon. Please just go ahead and ask your questions, please. Any question? Unmute yourself if you want to talk. Just mute button and you'll be unmuted and you will be able to know that you're hearing me. Just unmute yourself.
Welcome.
Thank you, Janet. How are you?
I'm fine. Hello, sir.
Yes, you're highly welcome. You're highly welcome. So,
thank you, sir.
Yes, in our last class, I felt that most of you course page on the e-learn, so I didn't paste the link of our classes there, but later I had to go back and paste it when some of you complained. So that I'm seeing so many of you here. I'm seeing Musa, Omar, Farouk. I'm seeing him. I'm just so happy with the participation. And I know in our subsequent classes too, more people will come. If I had sent messages yesterday, definitely I would have seen more people today. So I'm just so happy. So what I thought so class, I want to get your feedback. Janet.
Sir, I wanted you to share. I wanted you to talk this last point, this bulk density.
Yes. Okay.
I got it wrong. I
Okay.
didn't get it. Yeah.
So bulk density, just weight. He's talking about weight, or they call it mass of solid all over volume. Mass over volume. Mass is weight. Volume now, you understand? You know the formula for calculating volume. You calculate the volume of volume is if it is a cup, if it's a cylinder, you have to measure the volume. I think volume is half radius, half of radius, and this thing pi square, half r pi square, and all of that. That is the formula for measuring volume. Of course, mass is just measured in kg, either kg or in gram. If it's small, you measure it in gram. If you now measure in gram, it's not going to be mass is now going to be gram per cm cube. Gram per cm cube. You understand now? If it's a very big something now, it's not going to be kilogram per meter. You understand now? Per meter cube. You understand now? Mathematics very well, or physics and not really, but at least just take it as simple as that. It's a very simple stuff. And when you look at your study materials, you will also be able to understand more. So, any other? I don't know if you understand me now.
Yes, sir. There's a question I want to ask too on that.
Okay, go ahead.
The bulk density, still on that bulk density. The other time you said when the soil contains organic matter, so the weight, as in the bulk density, will be different. So I want to get that one very well. So the organic, because I have a soil at the back of my compound, which I put compost. I mix it with compost. It was formerly there was high content of clay in that soil, so I mixed it with compost. I left it for a very long time. Later, about some months, I discovered that the soil has changed and it has lost weight.
And that is just what I'm saying now.
Yes, I now want to repeat. I want to relate it to what happened in my backyard.
It's organic material. Remember, we talked about organic. Organic has to do with dead, decayed living things.
Yes.
It could be plant, it could be animal, it could be kitchen waste, it could be, those are organic. But the other component of soil that are formed from rocks, from parent materials, you understand? So they are denser, they are heavier. So that is what I simply mean, that when organic matter is more, such soils will tend to be less, and the bulk density of the soil will be less. Okay? I don't know if I'm understood now.
Yes, sir. I have gotten the point.
So that's the reason. The reason why the weight is because of the presence of the organic matter. The organic matter is organic. The soil component are the inorganic. The soil component are the heavy ones. They are the ones that make it to be very heavy. You understand now?
Yes, sir. Yes, sir.
So now, if you now go and measure it now and do the weight per volume, now you now realize that you may be having something like 1.2, 1.3. But if it's that original soil that you use that time, you now realize that it will be maybe 1.6, 1.7, and it is not very good for crop production, because the nutrient in that soil would have been lost. So I don't know if we have any other question. Musa Umar, I hope you are with us.
Yes, sir, I'm with you. Just that I am finding it difficult to hear what you guys are saying, because there is heavy rain here falling.
You said?
I said there is heavy rain falling right here where I am. Okay, so that's why I could not catch up with whatever you are saying, but I am.
So where is your location that you are enjoying that kind of rain?
It's Abuja.
Abuja. I'm actually in Abuja now. I'm at the headquarters, and the environment is changing too. So I just hope the rain will not stop me. So you're already getting your own showers of blessing. So you're welcome all. I just want to tell you all that I'm very, very happy seeing you all to be part of this class. Please always endeavor to be part of it. If you go to my
It's like network locking out. John, what's up? Friend default.
So it's like his network is off.
No, the network locked them out already.
He will log in.
Maybe,
He will log in back.
maybe he will
Just hold on.
try to
Hold on. Just hold on. He will log in again.